The next section is translation. The first part of translation is initiation, in which the first part of initiation is the small ribosomal unit, part of the two units of a ribosome, bonds to the mRNA strand made in transcription before, just right, so that the start codon, which is always AUG, is recognized by the ribosomal unit. And here we see that is in the proper position. The next step is the tRNA having the anticodon to the start codon in the mRNA right there on the small ribosome unit when it's binded, and it will bind through an H bond, and they bind through an H bond, and that is the second step. Just to clarify, the mRNA start codon is AUG, and the anticodon to that is UAC. The next step is that the large subunit of the ribosome comes in, allowing the tRNA with the methionine anticodon, or the methionine amino acid and the anticodon on the bottom to fully bind to the P site. And the A and E sites are brought in, and A will bring in the second amino acid to be produced. The next step of translation is elongation. The first step of elongation is codon recognition. As you can see, we have the mRNA through the ribosomal, both units, and it is seen that EP and A sites are established, and another tRNA with a anticodon and an amino acid, so an aminosyl tRNA, will come in and bind to the A site. However, there are a lot of tRNAs present in this step, but it only takes it's specified to one anticodon that's appropriate in order for the cycle to progress. GTP is also present in this process and makes it more efficient. The next step of elongation and translation is peptide bond formation. This is where a peptide bond is formed between the new amino acid in the A site, and it is to the end of the polypeptide chain on the tRNA in the P site. So the end of the peptide chain will break off and attach to the end of the new amino acid that came in through the A site, and the chain will be transferred to the end through peptide bonds. This is all done with the help of the large ribosomal subunit, which catalyzes the bonds. The next step of translation is not elongation, my bad, didn't erase that. It is translocation, and this happens when the old tRNA that was originally in the A site gets moved to the P site with its new polypeptide addition, and the one that was in it previously is moved to the E site where it exits the ribosome. Then once the A site is free of the tRNA, it is ready to bring in more tRNAs to find the anticodon that matches the mRNA and create more of the polypeptide chain. The final step in translation is termination. As time goes on, the polypeptide chain will grow larger or longer, and eventually tRNA anticodon will code for termination or tell it to stop creating the polypeptide. So that will go through all three steps of, or go through initiation and all three steps of elongation, and it will be here, and eventually the polypeptide chain will leave the ribosome and go into the cytoplasm to be made and folded into proteins, and it will have its function as a protein, or what kind of protein it is, determined after.